Good morning students, welcome back again to my channel. Today we are going to take one of the most important chapter, that is mole concept and stoichiometry, and the most important topic which is going to help you in your further exams, that is the empirical and the molecular formula. Let's start with the empirical formula. First of all, you should understand that what is the difference between empirical and the molecular formula. Empirical means the simplest formula of a compound containing the atoms of an element, and it does not give you the actual number of atoms, it provides you the number of atoms present in that molecule. For example, if I take C6H12O6, this is the formula of glucose, and this is the actual number of atoms present in the glucose compound. But we don't know that what is the real number of atoms of an element present in glucose. So what we have to do, we have to take a integer which is represented by n. What is the common integer among carbon, hydrogen and oxygen? It is 6, right? So if I take 6 by 6, 12 by 6, 6 by 6, I got C1H2O. So C1H2O, it does not represent the actual number of atoms in a compound, but it represents the number of atoms of an element present in a molecule. That is the glucose, right? But empirical formula is not considered as the chemical formula, because chemical formula, as you know, it gives you the actual number of atoms of an element. It is basically your simplest formula. So now we come to what is a molecular formula. Molecular formula is basically the actual number of atoms of an element present in a compound. Actual number of atoms of an element present in a compound is the molecular formula. Now let's see, if I take C4H10, this is my hydrocarbon and this is your butane. So it is basically your chemical formula that represents the actual number of an atom of an element present in a compound. So C4H10 is not your empirical formula. If I have to calculate the simplest formula for this, what I will take? I will take a common integer. The common integer here is 2 and it will be C2H5. But molecular formula is a chemical formula which represent the actual number of atoms of an element present in a molecule or a compound. So this is basically the difference between an empirical formula and the molecular formula. Now, there are certain relationship between empirical formula and the chemical formula. Let's find it out. What is the relationship? In molecular formula is always equal to n times the empirical formula. This is one of the most important formula which you have to find it out or note it down when you are doing the numerical related to this empirical and the molecular. Now n here represent the integer or any number. But when we talk about the integers can be positive and negative. But in case of molecular formula and empirical formula, you always take the positive value of the integer, because you know that the empirical and the molecular formula can never be calculated in its negative form. Second, the n value should always be present in its whole number, not in a decimal number. Suppose you have solved one question and you are getting n value in terms of, let us suppose 1.34. Then it means you have done something wrong. It should always be present in a whole number. The second is, suppose for the molecular formula and for the value of n, what two two things we require. We require molecular mass divided by the empirical formula mass. Molecular mass, you all know, I discussed in the video 1 that molecular mass is basically the sum of the atomic masses of all the atoms present in a molecule. So you can calculate the molecular mass. Sometimes it is given and sometimes it is not given. So I will tell you the trick to calculate the molecular mass. Molecular mass is also related to its vapor density. How? Let's see. Molecular mass is 2 times the vapor density. Sometimes when you see the questions of empirical and the molecular formula, the vapor density is given and you don't have the molecular mass directly. So you have to use this relation, and empirical formula mass means you have to calculate first the empirical formula of a compound, and then we will come to its empirical formula mass. Similarly, like we are calculating the molecular mass. Right? So these are the two relationships which you have to remember while finding out the molecular formula and while calculating the value of the n. Now let's take some of the numericals based on the empirical formula as well as the molecular formula. But before going to the numericals, let us proceed that whenever you are calculating the numerical, you have to make one table like this. This table is very important. It will comprise of your 6 columns, 2, 3, 4, 1, 2, 3, 4, 5 and 6. Now let's see what are these 6. The first will be your element. Right, the first will be your element. The second will be percentage composition. The third will be atomic mass. In this you don't have to solve anything. You will be provided with the element name, you will be provided with the percentage, you will be provided with the atomic mass. Only the next 3 columns are important, where you have to calculate the number of moles of an atom. The next you will find the atomic ratio, and from the atomic ratio we will calculate the simplest ratio. Right? So these are the 6 columns which you have to take when you are solving any empirical or the molecular formula of a compound. So now let's come to the question. First question is, a compound of carbon, hydrogen and oxygen is given, in which the percentage of carbon is 40%, hydrogen is 6.7%, oxygen is 53.3%. Atomic masses, you all know, these are some, I have already tell you the trick to find out the atomic masses of the element. If it's not given, please see my first video for its reference. The carbon atomic mass is 12, hydrogen is 1, oxygen is 60. Now you know how to calculate the number of moles. The number of moles I have already explained you in my second video, where I have explained you about the mole concept. It is the weight of the substance divided by its atomic mass. So 40 divided by 12, 6.7 divided by 1, 53.3 divided by 16. So when you divide 40 by 12, you will get 3.33. And when you, let me write 3.33, the second atomic mass is 1. Anything divided by 1 is the same. And 53.36, you will get again 3.33. Now we have calculated the atomic ratio. Now we have to take out, to calculate the number of moles. Now we have to calculate atomic ratio. You have to take the smallest number of moles. Out of this, which is the smallest number of moles here? 3.33. So we will divide all the number of moles by that value. Like for here, we have calculated 3.33. 3.33 equal to 1. 6.7, 3.3, let us assume it is equal to 2. and 3.3 divided by 3.3 is 1. So the empirical formula, carbon simplest ratio is 1. So let's multiply carbon with 1. Hydrogen simplest ratio is 2. So multiply it by 2. And oxygen simplest ratio is 1. So C1H2O1. This we got the empirical formula. I hope it is clear to you. Now, one more thing is given here. Calculate its empirical formula. We have already now calculated its molecular formula. If vapor density is 30. I told you to calculate the molecular formula we require two things. Molecular mass divided by empirical formula mass. But since molecular mass is not given, it is given vapor density, and you know the relationship. Molecular mass is 2 times the vapor density. And how we will calculate the empirical formula mass? By multiplying each atom with its atomic mass. So 1 into 12 plus 2 into 1 plus 16 into 1. So when you calculate, it will be 12 plus 2 plus 16, and 14 plus 16 is what? Is equal to 30. And let me do here. The molecular formula, molecular N value will be 2 times vapor density is 30, and the empirical formula weight also comes 30. So 30 got cancelled. So we got 2 as the answer. The relationship between empirical formula and molecular formula is N times the empirical formula, where N stands for the integer. Molecular formula we have to calculate. So 2 into, what is the value? C1H2O. C1H2O. You can see C1H2O. Now we will multiply. So it will be C2H4O2. So this represents the actual number of atoms present in a compound or in a molecule. I hope now you got an idea by using this table how to solve this molecular formula. If molecular mass is given directly, you can use the formula N is molecular mass and empirical formula mass. But if molecular mass is not given, we will be given a relationship of vapor density, where molecular mass is 2 times the vapor density. Now, we come to the next question. The next question is, this is the JE question which has already come. A compound contains 8.7% of hydrogen, 74% of carbon, 17.3% of nitrogen. Calculate the molecular formula of a compound if the molar mass of A is 176 gram per mole. Molar mass means that the molecular mass of a substance is given to you here directly. Again, we will make a table. We will write hydrogen, carbon, nitrogen element. Percentage is 8.7%, 74%, 17.3%. Atomic mass is 1, carbon is 12, nitrogen is 14. Now we will calculate the number of moles. Number of moles is mass of the substance divided by its molecular atomic mass. So 8.7, 74 divided by 12, and 17.3 divided by 14. So now let's calculate. 74 upon 2. It will be approximately equal to, if we take 74 upon 2, it will be approximately equal to around 74 upon 12, and we'll divide. It will be approximately equal to 6.02 something, and 17.3 will be approximately 1.33. So 12 6 are 72. What is left? 20. So 12 ones are 12, and we got 80, and it is 12 sevens is 12 6 is so 6.16, and it is coming 1.33. So which is the smallest in this case? It is 1.33. So let's divide. 8.7 divided by, it's like 14 ones are 14. What is left now? 14 1 is 14, so it will be your 33. 14 2s are 1.23 approximately will get. So 1.23, 6.16 divided by 1.23 and 1.23 divided by 1.23. You will calculate the atomic ratio, calculate the simplest ratio, and you will get the answer. So please, when you are solving this question, give me the complete solution. This is the assignment for you, homework for you. Complete it, and when you will get the simplest ratio, you will multiply each atom with the simplest ratio. Use the formula, molecular mass is already given. Calculate the value of n, and through that you will calculate the value of empirical formula. So this is all for today, where we have discussed the empirical formula and the molecular formula of a compound. Hope the concept of empirical formula and molecular formula is clear to you, along with the difference between the two formulas, along with the relationship, and along with how to solve the numericals related to this. So please keep practicing these numericals, and this is my another video through which I have made you understand that how to solve the question. Your accuracy in these questions depend on your calculations. If your calculations are fast, then you will able to solve these questions within 5 minutes. So solve it, and see you in the next video. If you like my video, kindly subscribe, like, and share my channel. Thank you.